So students, now let's talk about 4R functions which are available for normal distribution. They are described below as we can see. First function is dnorm, second is pnorm, third is qnorm, and the fourth one is rnorm. So students, when we are talking about dnorm, we are basically taking x as the vector of numbers, mean and standard deviation as the parameter. When we talk of pnorm, we take the vector of probabilities, we take x as the number, mean and standard deviation. When we take qnorm, we take p as the vector of probabilities, mean and standard deviation. And when we take rnorm, we take n as the number of observations, which is the sample size, mean and standard deviation. Now, let's talk about dnorm. This function gives height of the probability distribution at each point for a given mean and standard deviation. Let's understand this code and see how it happens. First, we create a sequence of numbers between -10 and 10 and incremented by 0.1. So you can see over here that I've called the sequence function from -10 to 10, and by incrementing 0.1, I'm storing the sequence result in x. Now, we choose the mean as 2.5 and standard deviation as 0.5. We can see over here that dnorm is my function which I'm calling. I'm passing my sequence vector x. I'm passing mean equals to 2.5 and standard deviation is equal to 0.5. So this is my set of values which I have passed for the probability distribution. Now, I give the chart file a name. As I can see, I'm calling the png function and giving my chart file a name dnorm.png. I call the plot function and I pass x, y as two variables. X is my sequence and y is my details about the normal probability distribution. We can see we save the file with the function dev.off, and now there is a graph which is plotted on the right hand side. You can see the graph where on the x-axis I have -10 to 10, which is my range of values. On the y-axis I have 0.0 to 0.8, which is my distribution. You can see over here that the distribution is reflected in the chart where you can see the probability distribution. You can see the distribution very easily with the graph, and we have used 4 commands. Mainly 4 commands are used to plot the graph. You can see the first one is the sequence command, which is used to create the list of numbers. Dnorm is giving the specifications about mean, standard deviation and the vector. Third is the png, which is creating the png file. And the fourth one is the plot command, which is plotting the graph between x and y. And finally, we have to save the file. Let's talk about pnorm now. This function gives a probability distribution of a normally distributed random number. So I'm saying there is a random number which is normally distributed. So what is the probability of a normally distributed random number to be less than that the value of a given number? It is also called cumulative distribution function. We call it cumulative distribution function. Create a sequence of numbers between -10 and 10, incrementing by 0.2. -10, 10 by 0.2. We choose the mean as 2.5 and then we have the standard deviation as 2. You can see in the y variable we are storing pnorm where x is my sequence, mean is my 2.5 and standard deviation is 2. You can see we give the chart title pnorm.png and again we plot the graph which is x, y. So now you can see the cumulative distribution function on the right hand side, which is the output. On the x-axis I have -10 till 10 and on the y-axis I have 0.0 till 1. Next I have the qnorm. Now this function takes the probability value and gives a number whose cumulative value matches the probability value. So basically the idea is that I am giving a probability value, that is my probability value, and which particular number whose cumulative value matches the probability value. So I want to find out that which number is having the particular probability value. Now, let's take the code one by one and understand. We have created a sequence by incrementing 0.02. Sequence is from 0 to 1 and increment is by 0.02. So, which means that I have the probability from 0 to 1. As we know that probability is always from 0 to 1. Now, I'm trying to find out that which particular number is matching that probability value. So, here my 0 to 1 has been divided into parts by a gap of 0.2. So you can see on the x-axis I have 0.0, 0.2, 0.4, 0.6, 0.8 and 1. As we know that the range of probabilities between 0 to 1, so x-axis will have a values ranging from 0 to 1. Then we choose the mean as 2 and standard deviation as 3. Now let's talk about the rnorm function. This function is used to generate random numbers whose distribution is normal. So basically, suppose I have to generate random numbers and the distribution is normal. In that case, I will use the rnorm function. Now, first of all, let's understand when can we generate random numbers whose distribution is normal. Distribution means that I have to generate random numbers and all the numbers are near to each other. There are no outliers. Let's say I have to generate random numbers between 0 to 3. So 0 to 3 is 0, 1, 2, 3, which are very close numbers. So here the distribution would be normal because exceptional cases are not there. If the numbers are from 0 to 80, in that case, their range increases. But when I'm saying I'm generating random numbers and the distribution is normal, which means the numbers are very near to each other. Or let's say I have to generate numbers in the range of 60s. Or let's say I have to generate numbers in the range of 60 to 63. So there the numbers are very close to each other. So when I'm saying distribution is normal, it means that the random numbers are close to each other. Sometimes there is a need that I have to generate random numbers and then the numbers are close to each other. Where can be such kind of case? For example, in a lottery, I want to give a discount of let's say 100, 101, 102 and 103. So all the four numbers are very close to each other. Now I am drawing a lucky draw and the random number which is generated, let's say 102, it is given to let's X customer, 103 given to Y customer and 104 given to Z customers. So in this scenario, we cannot assign a number or assign a discount to a customer. Rather, we are using a random number generation and then we are giving that particular discount to a customer. So in such scenarios, we generate random numbers whose distribution is normal. So this rnorm function takes the sample size as input and generate many random numbers. We draw the histogram to show the distribution of the generated number. Create a sample of 50 numbers which are normally distributed. So you can see over here y equals to rnorm and in the brackets we write 50 because the sample size is 50 numbers. So you can see over here that I have generated numbers with a sample of 50 numbers. So rnorm 50 and we have stored that in y. Now we give the chart file a name, png file equals to rnorm. So here the file name is rnorm and we plot the histogram where we call the hist function and within brackets we pass y, which is my list of random numbers, and I give the title as normal distribution. Finally, I save my file with dev.of function and then you can see in the right hand side the normal distribution. You can see the numbers have been generated. Now let's understand the normal distribution histogram. As we all know that on the x-axis I have the random numbers which are ranging from -2 to 2 and on the y-axis I have the frequency, which means how many times -2 has occurred, how many times a 0 has occurred in the list and how many times 1 has been generated and how many times 2 has been generated. So you can see over here that 0 is generated maximum times, -1 and +1 is generated a lesser number of times and -2 and +2 is generated even lesser number of times. And you can see that this is quite a bell-shaped curve. If we see, it is a normal distribution where it is sloping on both the sides. So you can see that this graph is basically a normal distribution where the numbers are generated in such a way that all the numbers are near to 0. So highest is 0, which is the mean, and lowest is -2 and 2. So that is how we can understand that with the help of R-norm, we have generated the random numbers. Now, let's talk about R functions for binomial distribution. R functions for binomial distributions are of 4 types: R binom, P binom, Q binom, and D binom. So, in this session, we will talk about one function and then rest you can try on your own. For that, students, you need to have prior knowledge of statistics. Whenever we are learning R programming, we need to have a prerequisite that we have good command on the statistics, and then we apply the functions, because there applying R functions on the data becomes very easy. Let's have a look what is binomial distribution. The binomial distribution model deals with finding the probability of success of an event which has only 2 possible outcomes in a series of experiments. So, I'm trying to say that what is the probability of success of an event? If there are 2 outcomes, suppose I'm tossing a coin which always gives head or a tail. So I'm tossing a coin. The probability of finding exactly 3 heads in tossing a coin repeatedly for 10 times is estimated during the binomial distribution. So basically there are 3 heads in tossing a coin, and 10 times I'm tossing the coin. Then in that case, what will be the probability of finding exactly 3 heads? So the idea is that if I have a coin and I'm tossing it 10 times, how many times will I get head? Will I get 3 times I will get head? If yes, what is the probability? So that distribution is called as the binomial distribution. Again, students, when we are dealing with R has 4 inbuilt functions to generate binomial distributions. These are D binom, P binom, Q binom, and R binom. You can see over here in the D binom, the 3 parameters are X, which is the vector of numbers, size, which is the number of trials, and probability is the probability of success of each trial. That what is the success of each trial. Likewise, there is P binom where X, size, and probability. There is Q binom where P is the vector of probabilities, size, which is the number of trials, and prob is the probability of success of each trial. And then we have R binom, which is N, size, and probability, which means the number of observations, size, and probability. Now, let's have a look of D binom function. Now, in the D binom function, this function gives the probability density distribution at each point. You can see over here that we have created a sample of 50 numbers which are incremented by 1. So numbers are ranging from 0 to 50 and they are incremented by 1. That sequence is stored in variable X. We create the binomial distribution, and in the D binom function, we have passed X, which is the sequence of numbers from 0 to 50. 50 is my sample, which is basically my size, and 0.5 is my probability of success of each trial. So you can see over here that the probability of success of each is 0.5. The reason that in the binomial distribution, there are only 2 outcomes, either true or false, either head or tail. So if there is a chance of head is 0.5, there is a chance of tail is 0.5, which means 50-50 chances. And that is why the probability in binomial distribution of success is always 0.5. You can see over here that in the D binom, I have passed X, 50 and 0.5, which is again stored in the variable R. Now we call the PNG function to give a file name, which is dbinom.png. We plot the graph with the variables X and Y, and we save the output with the function dev.off, and the result is there on the screen. You can see over here 0 to 50 is my result, which is the values from sequence from 0 to 50. And on the y-axis, I have from 0 to 1, which is the probability. Because we all know that the probability ranges from 0 to 1.